everyone, welcome back to you all to the Data Crack, where we break down the data and crack interview together. This is the day one of my branch, new 15 days statistic for data science series. In this series, we will cover all the important topic of a data science, mostly asked question from statistic. If you are a beginner or a fresher, or you are someone who are looking to gain a command in statistic for data science, then this is for you. Today we are going to start with the foundation. What is statistic? Why it is important in data, and what are its type? We will also take our first dive into a descriptive statistic which help us summarize and understand data pattern normally, right? So starting with the meaning or the definition of a statistic. What is statistic normally? Well, speaking about the statistic is normally the branch of a mathematic. It is normally the branch of a mathematic that involves collecting, analyzing, interpreting, and presenting data. It provides tools and methods that normally help us to understand and make sense of large amount of a data and draw conclusion and make a decision based on that data, right? In practice, statistic is used widely in the various field or range. Means we use statistic almost everywhere. For example, we use statistic in business. All right. In business, we normally use for analyzing data. For example, identifying customer behavior, demand, forecasting, and many more. All right. Similarly, we also use statistic in medical industry to identify the efficiency of a medicine. Similarly, in government and policies, even in government and policy, there is the involvement of statistic, conducting surveys, and all. Similarly, in environmental science, we use statistic. All right. Such as climate research, climate forecasting, and many more. Now, let's understand what are the important of statistic in data science. So, normally, when speaking about the data science, there is various importance. For example, it normally helps us to understand the pattern in the data. For example, I perform an EDA, okay, and EDA provide me some information that sales is related to customer, or sales do affect customer. Then I need to prove this pattern. For that, I can normally use hypothesis testing. Do this pattern is valid or not? All right. Similarly, it is normally crucial for data driven decision. Similarly, it is the foundation of a machine learning model. We normally use, just now I said, and we normally use in EDA, feature selection and hypothesis testing, model building and evaluation. Without statistic, data science would be like guessing in the dark. All right. So normally statistics help us to validate the things and help even us to gain the confidence on the result that we have achieved. All right. Now, well, moving forward to other type of a statistic. Normally, statistic is divided. Normally, there are two type of a statistic. Normally, we divide statistic into two part. The first part is descriptive statistic, and the second one is inferential statistic. Now let's understand what is this descriptive statistic and inferential statistic. All right. Descriptive statistic normally deal with collecting, organizing, analyzing, interpreting, and presentations of a data. It normally focus on summarizing and describing the main features of a set of a data without making any type of inference. All right. In simple language, you can simply understand descriptive statistic. You can just simply understand descriptive statistic as summary. All right, or the detail. Studying about the past. we normally study about the past thing in descriptive statistic, whereas in uh, inferior statistic is advanced than descriptive statistic. All right, in uh, advanced it is advanced. The reason it normally deal with making prediction about the population based on the sample. All right, sample. There are various tools and technique in descriptive statistic as well as in inferior statistic. So today we are just going to study about descriptive statistic in detail. What are mostly commonly used tools in descriptive statistic? So as we have already studied that descriptive statistic is a branch of a statistic that normally deal with summarizing and describing the main features of a data in a clear and understandable way. All right, it normally help us to understand our data at a glance before doing any advanced analysis. It doesn't make prediction or generalization, because inferior statistic deal with making prediction or generalization. Descriptive statistic is all about studying things in detail about the past information, not about the present. All right. So normally use tools or technique in descriptive statistic are, we normally have three. That is measurement of central tendency, measurement of dispersion, and shape of distribution. Even descriptive statistic is divided into three parts. One is measurement of central tendency, another is measurement of dispersion, and the last is shape of distribution. Let us study about what is this mean. So what is this inside measurement of central tendency? We have three tools. We normally have three tools or technique that we normally use. That is mean, median, and mode. We will study in deep what is this mean exactly, what is this median and mode, and why we need mean, median, and mode in data science. All right, so moving forward to where the measurement of central tendency normally deal. Well, speaking about measurement of central tendency, it is a statistical measure that represents typically a central value of a data set. It provides a summary of our data by identifying a single value that is the most representative value of our data set as a whole. All right. So, the first measurement of central tendency that we are going to study is about the mean. Which is also known as, we normally call it as the arithmetic mean. So, when speaking about the mean, it is normally the sum of all data point divided by number of observation that we are given. Normally, you can understand, we need to understand two things over here. We normally have two type of a mean over here. One is population mean and another is sample mean. All right. Sample mean. Population mean is normally denoted by mu is equal to, here we have formula summation, here we n is denoted by capital N, I is equal to 1, and summation I divided by n. Alright, this is the formula for population mean. And for sample mean, we normally denote it by summation n I is equal to 1 divided by n. Now, how we will calculate the mean? How can you calculate? For example, mean is normally the means sum of all value divided by n. Means it normally represent the central value of any data set. Alright. So, for example, I am provided with a column called, let's say, I am provided with a column called salary. Alright. Now, it is here I am given 5, just say 50, 50, 50, 50. In order to calculate mean, I will just simply do the total of this all, that is 50, 50, 50, 50, that is 200, right? And this is our summation x, and our n is means number of observation 1 2 3 4. All right, 4. Now our mean will be something like summation x divided by n. So 200 divided by 4, that is 4 5s are 20, means 50. Our mean is here 50. All right, we can calculate mean in this way. Now when should we use mean in data science? Imagine sometime we might have the missing value in our column. For example, here one of the value is missing. All right, here one value is not given. This is the missing value. This is the missing value. In such a case, in order to impute this missing value, we normally use min. But the condition is here that when we don't have, just remember this, we use min in data science for imputing missing value. Imputing missing value when we don't have outlier in our data. All right, in our data, when we don't have an outlier in our data, at that situation we normally use min to impute our missing value in our column. All right, now what is this outlier exactly? Well, speaking about this outlier, we will when our value is too high, or means some value are too high or too low, in such a situation mean don't work in an effective manner. Because for example, here we are given 50-50 and I will just write here 5 lakh. In such a situation, if I do the summation of all this, we can't get the actual representation, right? The reason we can't use mean. So in such a situation, what can we use? How can we handle this problem? In order to handle that problem, we normally use median. Even median is used. So what is this median? We normally use median for handling missing value only. For handling missing value, when we have an outlier in data, when outlier in data. So what is this medium? Well, speaking about medium, it is the middle value. Normally medium is nothing but it is just a middle value. All right, medium is the middle value in the data set, which after we have already arranged our data. All right, whether in ascending order or in a descending order. Here is also one condition, that after sorting the data, if our count is odd, we will use middle number. If even, we will use the average of that two number. All right, for example, in example you can already see that for here the medium is 18. All right, and here the median is 20 plus 30, means we have included this 2, because here we have the even or even value, even observation 1 2 3 4, means here we have used even observation divided by 2, and here we have got the 25. We normally use median, as I have previously said, that when we have outlier or our data is squeak, whether it can be the right squeak or left squeak. We will study about the data distribution later on in detail. In real world, for example, if I want to predict my house price in such a situation or income level, we normally use it to impute our missing value. All right. Now moving forward to another measurement of central tendency, which is mode. Now why we normally use mode? Mode is normally, let's understand first of all what is the definition of this mode. All right. So while speaking about the mode, mode is normally the value that appear most frequently in the data set. All right. For example, I have provided with one data. Let's say uh, gender. All right. And here I have provided like female, 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 male, female. Now, uh, what is the most frequently data over here? That is female, right? This is our mode. This is our mode value. Means most frequent value represent normally the mode. All right. So, why we need mode? Why we need to understand mode, and when we will use normally mode? Normally, when we have the missing, even when we have a missing value, when we have missing value in our data set, in case of categorical column, then we normally use mode. All right. So let's understand in summary. Normally we have studied that in descriptive statistic is all about studying data in detail, studying data about the past, right? About the past. It doesn't deal with making any type of inference and all. Even descriptive statistic is further divided into three parts. The one is measurement of central tendency, measurement of dispersion, and finally shape of distribution. As we have already studied about this measurement of central tendency has tool called mean, median, and mode. Even sometimes we use weighted mean to add the weight to our any value. All right. So mean, we normally use this mean, median, and mode in our data science normally to handle a missing value. All right. Whenever we have the missing value, handling the missing value. For example, we normally have two type of a data. All right. Two type of a data: numerical data and categorical data. For numerical data, we normally use mean and median. And for categorical data or categorical column, we use mode. When we have outlier in our data, we use outlier. Liar, we use median. Otherwise, we use mean. All right. Now moving toward the measurement of dispersion. So what is this measurement of dispersion or variability? While speaking about the measurement of dispersion or variability, a measurement of dispersion is a statistical measure that normally describes the spread or variability of a data. All right. It provides information about how the data is distributed around the central tendency, that is mean, median, or mode of the data. All right. For example, we have different type of a tool called range. Range is normally the difference between maximum and minimum in the data set. It is normally rare use, means we don't use that much. Similarly, the another tool here we have is the variance. All right. We normally variance normally use more variance. Variance is the average of a squared difference between each data point and the mean. It measures the average distance of each point from the mean and is useful in comparing dispersions of a data with different mean. While speaking about the formula for variance is normally variance is summation and I is equal to 1 xi minus x bar whole square divided by n. Alright, this is the formula for variance, and we normally even use the variance during our machine learning for calculating the slope. When we use the function means loss function, we normally use the variance only. Alright, now moving ahead to another measurement of dispersion, which is standard deviation. Well, speaking about the standard deviation is nothing but it is simply the square root of a variance. Means standard deviation is simply the square root of a variance. All right, square root of a variance. Now most of the time in interview we are asked that why we normally prefer standard deviation for why we normally prefer standard deviation than variance. In such a situation you can normally say that standard deviation is in same unit. Alright, same unit as our original data, whereas variance is in squared unit. Standard deviation being in same unit makes it easier to interpret with real world data. Alright, now moving forward to interquartile range. It is normally the range of a middle of a 50% of the value. It removes the effect of an outlier. We have the formula for interquartile range is Q3 minus Q1. Alright, we have here formula that is Q3 minus Q1. Where our Q1 is the 25th percentile and Q3 is 75th percentile. Whenever you are given Q1 is like 20 and Q3 40, in such a way you can get your interquartile range. 40 minus 20 is 20. When we want to robust spread ignoring outlier, at that situation we normally use when our data is left sweep or right sweep, at that situation we normally want to remove the outlier. In such a situation we can normally use interquartile range. Alright, now in the next video we will study about the shape of a distribution. I hope you all understand the descriptive statistic. In descriptive statistic, measurement of central tendency and measurement of dispersion. In next video we will focus on the shape of distribution, what is swag distribution, what is kurtosis, and the visuals tool that we normally use to see the shape of a distribution, such as histogram and box plot in detail, what is 5-number summary, which is mostly asked interview questions. Yeah, thank you so much.